gentlemen, thank you for your participation and welcome to the 45-8 Energy presentation. 45-8 Energy is a French startup created in 2017 by 5 co-founders and dedicated to the exploration and production of strategic industrial gases which are essential to the ecological and energy transition, such as helium and natural hydrogen. Our approach focuses on short supply chains, enabling human-sized local projects targeting a nearby consumption. Our pioneering and innovative approach allowed us to develop a unique portfolio of exploration projects and has been praised by strong and renowned labels and awards. We recently received by the French Ministry of the Ecological Transition the Green Tech Innovation label for our first project, thus demonstrating the positive impact of such approach to the ecological transition challenges. We also have been selected as part of the Recovery Plan for Strategic Industries with a grant of 1.6 million by the French Ministry of Industries. Several of our R&D projects have also been labeled by competitive clusters, demonstrating our technical relevance.
First, a bit of theory with a very brief comparison of key elements of helium and natural hydrogen geological systems. So let's start with helium on the left side. For accumulations with very important volume and concentration, helium comes mainly from uranium and thorium radioactive decay. Primordial helium from mantle degassing, those contribute also, it's true, but isotopic analysis have demonstrated that the associated volume is really low and then insignificant. Radioactive decay is a function of time, and specifically half-life of the radioactive elements. So generating large volumes of helium can be really time-consuming. For example, if you take 1 cubic kilometer of an uranium-rich conite, so with 250 ppm of uranium, for example, it will only generate 50,000 cubic meter of helium by million year. So just to give you an idea, it's enough to fill half of the last generation airship only. Real case studies around the world are unanimous. The older the reservoir seal system is, the higher the chance is to encounter high helium volume and or concentration. So what about hydrogen now? Except for water radiolysis, natural hydrogen mechanisms don't have relation with uranium and thorium. For example, serpentinization, redox reactions, or mantle degassing. Also, in comparison with helium, which is an inert gas, H2 is a quite reactive molecule which has plenty of combination options within the subsurface. Then keeping hydrogen at H2 state in long-term trap seems to be quite challenging. Such observation tends to be demonstrated by published papers about Mali or Brazil, for example, where present-day generation or temporary accumulations are considered as most likely. In conclusion, considering those elements, it seems to be difficult in theory to find both helium and natural hydrogen in interesting volume and concentration in the same reservoir. However, as you know, Mother Nature loves to show us when we are wrong. So in fact, helium and natural hydrogen are found combined in many places in concentration and in volume. On the slide here, you have some example of well data in Brazil, US, Europe, Mali, or Australia, where helium and natural hydrogen are found together. So for those of you who are not very familiar with helium, depending on operational context and byproduct, helium can be commercially valuable in the field from around 400 ppm of helium, like in Qatar for instance, and it is extremely rare to find more than 3 or 4% of helium within a commercial volume of gas. So how it is possible then to find helium and natural hydrogen together? First hypothesis, hydrogen can be an efficient gas vector for helium in some specific geological context. On the cross-section here, first, throughout time, you have an in-situ generation of helium within a uranium-thorium-rich basement. Then later on, you have a generation of hydrogen within the same basement, plus a potential mantle contribution. And finally, migration starts, and by diffusion mechanism, the migrating hydrogen is carrying in situ helium toward the potential trap. It is very important to remember that helium cannot migrate alone, and it needs a gas vector. Depending on the geological context, it can be nitrogen, methane, CO2, and potentially natural hydrogen. It is the reason why a pure helium-bearing reservoir has never been found. A lack of gas vector is a common explanation for not finding helium in the context where, on the paper, all the elements, however, exist. So, second hypothesis, a late migration of hydrogen in a reservoir already containing helium. So classically, you have a migration of first gas mix composed of helium-nitrogen or helium-methane in a trapping system. Then, later on, you have a generation of hydrogen within the basement, and once again, plus potential mental contribution. And finally, we assist to the migration of the generated hydrogen into the system up to the initial gas accumulation, involving then initial gas mix deletion.
So, based on what has been mentioned by Clément, let's investigate how valorizing helium on top of natural hydrogen can help to strongly improve the project attractiveness. First, let me give you a brief overview of the helium market. Several countries, or even Europe, have flagged helium as strategic resource and supporting exploration and production initiatives. Several reasons for that. There is limited number of production sites around the world, about 30 with more than 2/3 in US. There is then a clear unequal distributed production. Okay, you will tell me like many resources as oil and gas, for instance. Okay, it's true, of course, but with the specificity for helium that the resource is quite difficult to transport on long distance. For that, you have to liquefy it at minus 289 degrees Celsius, to use specific high expansive containers, and you have a quite limited period of time to deliver your container to avoid parts of resource loss. In front of this complex supply chain, the market is facing a boom of helium use, especially in the new tech. I will provide more details on this in the next slide. No effective substitutes are available for the main uses. We cannot synthesize helium in a sustainable and economical manner. And historically, in the last century, we never specifically explored helium, and when we found some, it was mainly a very low fraction of the gas mix in presence, and mainly associated with natural gas. This gas is highly interesting thanks to its unique qualities. It's an inert gas, lighter than air, small, showing a very high thermal conductivity, 3,000 times the copper one. For that reason, helium is crucial in many sectors. Helium is, for instance, more and more used in high-tech electronics, LCD screen, semiconductors, fiber optics, for high-efficiency cooling, like in MRI scanner, for lifting, with, for instance, the current growth of airships market that will be back significantly in our skies this decade, and many other sectors like laboratories, space industry, gas mixtures in medicals. It has been, for instance, COVID-19 treatment mixed with oxygen. Problem. Most of current production facilities are at maximum production level, and helium market has faced multiple shortages in the last years. Consequences, helium price has more than doubled in the last 5 years. Helium market is growing fast, especially in value. Analysts such as Hargreaves, for instance, in May this year, predicts a market value increase from $10.6 billion in 2099 up to $15.7 billion by 2023, nearly 50% increase in 4 years. There is currently a consensus between analysts to say that helium market is far too dependent from a too restricted amount of production sources around the world. A more diverse supply portfolio would therefore be wholesome. This issue can clearly be an opportunity, and in particular for natural hydrogen explorers. Helium price is 30 to 60 times higher than hydrogen, depending on market and required process. Then, even a small fraction of helium in a natural hydrogen gas mix can bring a significant added revenue. Okay, let's take an example where helium can definitely bring added value in parallel of natural hydrogen production, Western Europe. 100% of helium is imported. It's the second worldwide import market with 31 million cubic meters per year. The market is in continuous growth, a bit like most of the other continents actually. It is mainly a gaseous state helium market, 74%, but the entire volume is imported at liquid state, mainly from US, Qatar and Algeria. Then, there is clearly some room for local production directly at gaseous states to feed a local and demanding market. Energy consuming and EV helium liquefaction process can then be bypassed, minimizing cost and carbon footprint.
Let's talk about strategy. How can we build a long-term and virtuous business? The 45-8 energy strategy can be summarized in 3 pillars. The first one is co-valuation, meaning that we do see the diversity in the gas mix as an advantage rather than a drawback. It creates opportunities, in particular in areas where our predecessors had often given up because they were too monospecific in the resource they were chasing and unable to find a proper way to develop their finding. In other words, co-valuation approach just broadens our playground. The second pillar is to look for lean supply chains. We always privilege a local valuation of the resource, and yes, it forces us to be innovative because each case is different, but also pushes us to invent fit-for-purpose infrastructures, which at the end can be extremely competitive in terms of process and transportation, with therefore a much lower carbon footprint. And the third and last pillar is that we prefer to value resource at the gaseous state, not liquefied, and the process is much simpler, and most of the customers in Europe, in addition, use helium or hydrogen as a gas and not a liquid. So the playground is large, but we need to deploy efficiently our efforts to deliver. So how to do so? First, we shall accept to fail fast, meaning that systematically we shall reject a project which exhibits a high risk or low stakes and cannot be further de-risked. And this is why we develop a progressive maturation workflow or funnel to find the good enough amount of work to deploy depending on the maturity or the potential of the project. And this starts with the first step of regional screening in basins which have, in theory, the geological ingredients to be prone for helium or hydrogen. And after a rapid overview, we decide if a specific area in this basin has or not a particular interest. It has, for example, shows reported, extensive data available, no competition, and then we can study the relevance to apply for a permit within an area which has now a reasonable size. Which acquisition can further de-risk it? Which stakes for which risk? How can be developed the project and at which cost? Here are typically the questions we shall study prior to officially apply. Then, moving to the next step, which is the award of the license, can be quick in some countries, a bit tougher in others. And this is why we shall look at multiple projects in parallel to avoid being stuck. When the license is secured, then we can deploy our exploration program and decide at the end to drill a drop. Exploration drilling obviously is intended to strike gas, and we need to appraise it. And at the end, this is the main goal, to produce it. And the key in this system is the more projects we screen up front, the more resources we will deliver at the end. So how to proceed? First, we shall be humble and take care to geological bias. Some very interesting areas where we are working today had on the paper no real reason to be so prolific, and in the contrary, other had on the papers all the elements but failed to deliver. Nature is unfortunately so many times counterintuitive. And this is why the really first step is to carry out a systematic screening, and we basically study all the onshore basins of Europe. One by one, we rank it based on multi-criteria, and including non-geological ones. And during this exercise, we track every weak signal. It can be from a well, and not only oil and gas wells, it can be also geotechnical. They are very instructive. It can be a natural spring, soil gas sampling, a processing field, whatever. And it proved to be such an efficient driver that we spent quite a lot of efforts these last years to build a specific database that we call the GeoData Gas, which aims to report any gas composition that is reported over the entire world, focusing obviously on helium, hydrogen, but also CO2 or nitrogen. Being the pioneers, the really first ones to chase a new resource is a privilege, because we can, for instance, explore onshore and at shallow depths. And this is typically an area where we can deploy multiple geophysical methods at very low cost. In areas that we operate currently, we already acquired, for instance, gravimetry, which can provide a really good structural mapping, able itself at that stage to indicate prospective structures. Electric resistivity tomography, or ERT, where we inject electric currents into the ground, which is then measured by multiple electrodes deployed at surface, is also a cheap and very efficient tool that we successfully implemented to look at precisely fault locations and 2D profiles, and this will be very helpful to locate our future boreholes. Electromagnetics, or CSEM, is another very interesting tool that we also deployed. It indicates potential resistivity anomalies in the subsurface, which can be direct indicator of gas presence. And we identified some very interesting one, and future drilling will give the answer. And who said that seismic is only reserved for oil and gas business? We discovered that new service company ecosystem has emerged, making seismic acquisition affordable for smaller size projects, as can demonstrate this first profile acquired by us last year. Finally, we do also consider geochemistry as a must. We conducted already quite a large number of solid gas sampling surveys to detect potential helium or hydrogen anomalies at near surface, and this can be possible indicator of gas accumulation deeper. And it's only starting. We are committed to deliver our first production in a few years from now, and we are planning to acquire a 3D seismic in 2 months to perform some well testing or even drilling by the end of this year. So as you can see, exploration in 45.8 energy is not only on the paper.
It is clear that an emerging industry like natural hydrogen could not grow and overcome its challenges without innovations. In 45.8 Energy, we believe that a strong R&D program is mandatory to reach our objective to find and produce economic helium and hydrogen from the subsurface. There are a couple of reasons why an ambitious R&D strategy is key for a company like ours. First, to optimize our E&P program by increasing the probability of success of our projects, reduce their timeline, and consequently reduce their total cost. Second, to reinforce our technical credibility and give us a competitive advantage over our peers. We want to be seen as a technical leader on natural hydrogen exploration and production. And finally, it's also an opportunity to develop technologies in harmony with our values, technologies that are eco-friendly, cost-conscious, and efficient. To achieve this ambition of technical leadership, 45.8 Energy has launched a complete panel of projects in the upstream, but also downstream sector. This downstream part will be presented later by my colleague Anaël. From an upstream perspective, we lead or we take part of several projects presented on this slide. These projects involve industrial sectors from different sizes, from startup to majors, state-controlled entities, and research labs. Some of them are focusing on removing technological barriers, while some focus on testing and adapting existing technologies. The first project I would like to present you in detail is a connected probe called Seaground. It is well known, thanks to various publications, that hydrogen does not leak continuously from the subsurface, but more on a pulse basis. It is therefore mandatory to find a way to monitor this flux over a long period of time, and this is the aim of the Seaground probe. There was no such kind of tool available on the market for a specific application, so we developed, in partnership with 3 entities, a connected probe, or IoT, dedicated to subsurface gas analysis. We highlighted 5 major key elements that our SIGROUND probe should treat. Being able to measure over a long period of time on a narrow basis, send the data automatically from a remote area, minimize our interventions, being cheap enough to mesh our area of interest with several of them, and finally, being able to handle subsurface constraints like humidity. We have worked on 2 aspects: the sensitive element, which is based on a semiconductor technology, and the device, which will combine the sensor, the electronics, the communication system, and the battery. And here's what our prototype probe looks like and what are its technical specifications. I will not go in detail, but feel free to recontact us later on to discuss it. It's a 1 meter long tube that is almost entirely placed into the ground. The gas chamber with the sensitive element is at the bottom on the left of the picture. Sensors for humidity, temperature and pressure are also integrated into the probe close to the H2 sensor. The electronic card, the battery and the communication system are all installed in the upper part of the probe. On top of our research and development project, and especially the one presented before, we have spent the past 3 years and a half to optimize our sampling capabilities. Indeed, the first approach in helium and hydrogen exploration is based on targeting leaks in the near surface. It could take various forms, from escaping through bubbling sources to diffusivity into the soil. These leaks happen in various environments, in agricultural or forest soil context, associated with geothermal or gaseous water sources, or near major faults. Whatever the conditions, we develop methodologies and tools to sample properly these gases and transport it into our lab. On the picture on the left, you can see one of our self-designed probes, allowing to take both measurements with sensor and vacutainers at the same time. It is particularly interesting when you are in an area with little information and be able to select the best samples to send to the lab. On the right, you can see one of the techniques used for isotopic sampling. To be fully autonomous and responsive in our exploration, it has been clear that we needed our own analytical capabilities to study the samples collected during our field campaigns. So we invested and built an internal lab with equipment specifically dedicated to the measurements of helium and hydrogen, even for very low concentration. And I'm talking about tenths of ppm of precision. Because of this need for precision, and because dealing with small molecules like helium and hydrogen is challenging, it requires sophisticated preparation, sampling, and analyzing protocols. This investment allows us to capitalize on our know-how, allows us to control the quality of the data, and of course, optimize our costs, because so far we have collected thousands of samples since the beginning of our journey. Finally, as already shown by Benoit on our exploration strategy, we have built a network of reliable partners and contractors through different collaborations. It is key to add some technology to our exploration tool portfolio, and we have conducted several projects to find those who are the most beneficial for the H2 exploration. Passive seismic is one of them, for example, as this technology helps us to locate precisely a natural gas flux in the subsurface, usually along major fault. Radon could also be a good tracer of deep interactions. The hydrogen ecosystem is in construction, and sharing our technologies and our developments with the firms and academics involved will help us to demonstrate the economic viability of this industry.
Three other R&D programs are dedicated to downstream. The first one aims to develop a gas separation process able to produce helium and hydrogen from non-hydrocarbon resources. The second one, with IMT Mindales, aims to carry out a life cycle analysis of eco-responsible helium production in Europe versus conventional production of helium from natural gas in US. The last one is led by GEFIS consortium, which bring together key actors of the subsurface industry, French Ministry of Ecological Transition, industrial, universities, research institutes, and national institutions, in order to establish a complete knowledge and methods based to better integrate subsurface projects within territories. All these R&D programs are related to our desire to propose a new approach for helium and hydrogen production. This approach is based on the use of a mobile production unit during extended well tests. There are multiple objectives. The first one is to avoid atmospheric emission during well tests. The second one is to validate the separation process under realistic conditions. And the last one is to evaluate the production capacities before industrial scale-up. The advantages of mobile production units are numerous. The unit valorize helium, hydrogen, but also co-products like carbon dioxide. Secondly, the production unit allows flexibility of the inlet condition, so it can be implemented on several sites during its lifetime. Finally, the production unit has low footprint and low impact on environment. In the production unit, we chose to use membrane technology. This technology is based on the capacity of some membrane materials to separate molecules. Helium and hydrogen have very similar behavior in polymeric membrane. So development made for helium separation can be easily transposed for hydrogen production. Membrane processes are very interesting because there is no use of chemical products, footprint is very low, and it's an ambient temperature process. So energy consumption is low compared to other separation processes like liquefaction, for instance. Our first mobile production unit will be developed as part of Prometeo project. So this 3 years project is carried out in partnership with LRGP, Laboratory of Reaction and Chemical Engineering in Nancy. A part of the project will be financed by France Relance, a grant dedicated to industrial development in strategic sector.
Finally, within 45-8 Energy, we are strongly believing that technical and business collaboration are the best way to speed up the emergence of a strong and visible natural hydrogen sector. For that reason, we are highly active in several technical and competitiveness clusters. We are also at the origin of Earth2, an initiative with two main objectives: federate academic and industrial actors working on subsurface hydrogen and promote the contribution of subsurface in the hydrogen industry, currently not enough considered by decision makers. The initiative is currently under construction for an official launch this summer. 90 expressions of interest have already been received to date from corporates, academics, state agencies, freelance. If you are interested, feel free to have a look to the dedicated newsletter on HNAT Summit website. If you want more information, I invite you to follow the specific workshop organized by HNAT, where HNAT, 45-8 Energy and BEAM are sharing their vision of a collaborative way of approaching this natural hydrogen sector. To conclude, 45-8 Energy, created 4 years ago, has chosen to follow this hydrogen-helium co-valuation strategy since its beginning. The company has developed and is continuously developing a unique portfolio of exploration projects under maturation in already 9 countries, with already 2 exploration license applications in Europe, one to be awarded in the coming days, a first gas expected for mid-2023 in France, building a high-tech mobile pilot unit developed with the support of French government, the French National Research Center, and the Lorraine University. Finally, mid-June, we are going to start a new fundraising campaign with the objective to accelerate the company development in securing additional high-potential acreage in new countries and finalize the production pilot funding. Feel free to contact us if you are interested in participating for partnership in one of our projects. Farming opportunities are already available and others will come in 2021-22. Thank you very much for assisting this workshop and feel free to discuss during the conferences. Thank you.